Hello again to my ECG series. This lecture is about atrial tachycardia with AV block. It's a common problem, and it happens because of the way the AV node behaves. A V node is like gatekeeper of the heart. It allows only selective impulses to pass while blocks the rest. A V node is not capable of rapid conduction, in part because the cells of the AV node depolarize, because of calcium currents that run into the cells, and the action potential has a much slower upstroke than the sodium-dependent cells of the bundle branches and the Purkinje fibers. So the AV node behaves in such a way that if the atrial rate is excessively rapid, the AV node will fail to conduct all those impulses. So if the atrial rate reaches a certain point, the AV node will not be able to let those impulses through on one-to-one basis, and you'll start to see a V block occur by virtue of the rapid atrial rate. So atrial tachycardia with block is a very common diagnosis, and it's based on the way the AV node behaves when the atrial rate gets too fast. Now it doesn't matter if you have an atrial tachycardia that's due to re-entry, or if you have an ectopic focus that's firing rapidly. If they're above whatever rate the AV node is capable of conducting, then you'll encounter some degree of AV block, and we'll show you different presentations of this. So here is an example of an ECG. It's a 12 lead. And as you scan across, you look at the farthest first, you'll notice that there seems to be some kind of irregularity, but there's a regular pattern to it, so you can call it regularly irregular. Specifically, I see groups of 4 QRS complexes followed by a pause. 4 QRS and a pause. So you have a group beating pattern. Each group is 4 QRS in duration. Now when you hear group beating, you should think AV block. You have to start to think of Wanky back, because type 1 second-degree AV block often presents with group beating. And I tell people, when you see group beating, the first thing you have to do is look for P waves and see if you have AV block going on. If we scan this ECG, where is the best place to look for P waves? Well, I think the best place to look for P waves is in the little pause here, because when you have a period where there are no QRS, it gives you a good chance to look for P waves. And I would say that this is one right here. Let's look at some other leads during the pause. Indeed, you have P waves here, which you see in another lead, and in fact you have one here in lead 1. So at the end of each pause, there appears to be a P wave that conducts to the QRS complex with a borderline PR interval. It's close to 200 milliseconds. But look at the P wave morphology. It's up a little bit in 1, but you notice it's negative in AVF. In fact, 2, 3 and AVF are all negative. So this P wave is originating from somewhere in the low part of the atrium and traveling up towards the head. So this is clearly some kind of atrial arrhythmia. It's not sinus. The trick is to try to figure out where the rest of the P waves are. So if you kind of scan in between, I hope that you would actually notice that this very sharp deflection here, midway between the two beats, is the next P wave. And if you kind of scan across, you see another one here and then one that's even here. Now what you should notice is that the relationship between the QRS complex and the subsequent P wave is changing. Notice that this R to P interval is longer, and then the P comes a little bit earlier, and then the P comes even earlier still. The relationship between the Ps and the QRS are changing. If you look at the PR interval, in fact you can see the PR is getting longer, and then longer still. Now the question is, are these P waves regular? Because if they are, then we are looking at type 1 second-degree AV block. So let's pull out our calipers, let's move our calipers around. And if you put it on the first P wave, and then I've set it up so that you are on the next P wave. Now let's march them on through. And you can see this P wave occurs at the same interval. It's on time, and this P wave seems to be on time. And if you keep on moving it, you see this negative deflection here. And if you put your calipers, you see that this occurs on time as well. So the P to P interval is regular. The rate, if we put the calipers on a heavy line, is about 120 beats per minute. So you have this ectopic atrial tachycardia at 120 beats per minute, and the PR intervals are getting longer. And then this P wave right here fails to conduct. And then the next P wave occurs on time and conducts with the shortest PR interval of the whole cycle. So the diagnosis here, we know it's not sinus. It has to be atrial tachycardia with block. Now, what kind of block? We can call it wonky back. So you should be able to look for these P waves, map them out, determine the relation between the P's and the QRS complexes. Notice the P's were coming earlier and earlier in the RR interval, and that's because the PR was getting longer. Then this one clearly occurs on time and it fails to conduct to the ventricles. It's not a non-conducted atrial premature beat. That P wave occurred on time, it just got blocked in the AV node. Alright, that's it for today. See you in the next lesson.